Hey, what's up everybody? My name is Moss, and in this video I'm going to show you how to connect to a Postgres database using Golang and the PGX Postgres driver. This video is a continuation of the introductory series on gRPC using the Go programming language, and if you haven't watched the previous videos in the series, I encourage you to do so, but it's not a hard requirement to watch the previous videos in order to gain value out of this video. The focus of this tutorial is familiarizing yourself with the PGX interface, and that knowledge can be used independent of gRPC. So if you're not interested in the gRPC portion of the tutorial, that's okay, because most of the tutorial is going to focus on interacting with the PGX interfaces. And whether or not you've been following along with the series, I encourage you to clone down the code base that we're going to modify and check out the branch called part 3 JSON user data. If you intend on running the program locally on your machine and you haven't been following the series, then I would encourage you to go back and watch the first video of the series, because there I'll show you how to compile the program using the protojson tool, which is a prerequisite for compiling the gRPC service that we've written. The other prerequisites for this tutorial is that you have Postgres either installed on your machine, or there is a Postgres instance that you can connect to. You should also be familiar with SQL and basic database concepts. Now, in the previous video, I introduced you to the protojson package, and I showed you how to write out JSON formatted user data to a file, and then we read from that file all of the users that we had previously created anytime a client called the GetUsers function. We want our gRPC service to be scalable, and the protojson solution is scalable up to a certain point. Past that point, protojson is no longer a practical solution, and we need to use an actual database for our gRPC service. If you've enjoyed this series so far, please consider throwing a like on the video and subscribing to the channel for more series like this. So if you haven't already, go ahead and grab a coffee and let's get started. Okay, so I have the code base opened up in VS Code, and I also opened the user management server.go file. This is the only file that we need to modify in order to basically migrate our gRPC service from protojson to using Postgres. And also notice in the terminal that I'm checked out to the part 3 JSON user data branch. And the first thing that I want to do in the server code is remove all of the logic related to protojson. So the first thing that I'll do is remove the import statement of protojson. And then let's navigate down to the CreateNewUser function. And I'm going to delete lines 46 through 48. I'll keep the created user variable here, but I am going to delete the initialization of the ID attribute. And then I'm going to delete all of this logic marshalling and unmarshalling the JSON data from the users.json file. So I'm going to delete lines 48 through 62, 63 actually. And we'll also remove lines 49 through, lines 49 through 59 here as well. Okay. And in the GetUsers function, we'll also remove all of that JSON, protojson logic as well. So I'm going to delete lines 53 through 60. Actually, I'm going to keep line 57, so I'll delete 53 through 56, and then 55 through 57. Okay, so we'll keep this users list variable. So now that we've deleted all of the protojson logic, let's go ahead and import the PGX package. So up here, the package is github.com jackc pgx v4. Once we've imported the PGX package, we're going to modify the user management server struct, and we're going to add an attribute called connection. So connection, and it's going to be of type pointer to a PGX connection. Okay, so PGX.con. Now that we've added that attribute, let's begin modifying the CreateNewUser function. And the first thing that I'm going to do in the CreateNewUser function is define a new SQL statement. And in that SQL statement, we're going to create a new table called users in our Postgres database if a table called users doesn't already exist. Now in practice, you might not be creating tables very often, so it might be better to create the table from the command line. But really, I just want to exercise the PGX interface so that you can get familiar with it, and that's why I'm creating the table in the code base itself. So I'm going to define a new variable, and I'm going to call it CreateSQL. And I'm going to use backticks so that I can create a multi-line string. And we'll say create table if not exists, and we're going to call it users. And it will contain the following fields. The first field is going to be ID, and it will have the serial property, and it will also be the primary key. So what this means is that we no longer have to generate an ID ourselves. The Postgres database is going to automatically generate an ID for us, and it will auto increment that ID as we add new records to our users table. And the next field is going to be the name of our user. This is going to be text. And then finally the age of our user, which will be an integer. And then I will close out that statement. So now that we have that SQL statement, we can use the exec command to actually execute that SQL statement on our Postgres database. So I'm going to go ahead and call the exec command. I'll first define underscore for the first return value of exec, and then for the second return value, we'll define error is equal to server.connection. Okay, so we're referencing the connection attribute of the user management server .exec. And the exec command takes as input context.background. And then the second argument is going to be our SQL statement. And then after we call the command, we'll check for an error. So if error is not equal to nil, we will printf to standard error, and we'll say table creation failed. And we'll exit. After the users table gets created, or it doesn't get created because it already exists, we'll then insert the user that we received from the client as a new record in the users table. So directly after we create a new user struct down here and we define the created user variable, we're going to begin a new database transaction with our Postgres database. And I'm going to move this log statement up to the top. Okay. One thing that I'd like to note is that it's not necessary to use a transaction in this case, since we're only inserting a single record into the user's table. But I just want to get you familiar with the transactions interface in addition to the exec command that we use to create the user's table. So below the created user variable, I'm going to define two new variables, tx for transaction and then error. And we're going to call server.connection.begin. And then we're going to pass in the context.background. And after we call the begin function, we'll check if there was an error. So if error is not equal to nil, we'll log fatal connection.begin failed. However, if there's not an error, then we will call the exec command on our new transaction. So to do that, I'm going to define underscore for the first return value, and then error for the second is equal to server, tx.exec, and then we'll pass in the context.background. And then the second argument is going to be our SQL statement, and we'll enter it in line. And that statement is going to be the following: insert into the users table in the name and age field the following values. And then we're going to use variable substitution here, $1 and $2. And then we can specify the variables that we want to pass in to this statement. And the variables that we're going to be passing in are the created user attributes, okay, that we defined up here that we got from the client. So I'm going to reference created user dot name, and then created user dot age. And after we call the exec command, we'll check if there was an error returned from the command. So if error is not equal to nil, we'll log fatal tx.exec failed. And if there wasn't an error returned by the exec command, then the last step that we need to perform is commit the transaction. And to do that, we simply call the commit command on our transaction. So tx.commit, and then we pass in the context.background. And that wraps up all of the code that we need to write for the CreateNewUser function. The next function that we want to modify is the GetUsers function. So in the GetUsers function, all we're doing is reading from the users table in our Postgres database. And to retrieve rows from our users table, all we have to do is make a call to the query function. So what I'm going to do is I'm going to define two new variables. The first is rows and the second is error. And then we will call the query function. So that'll be server.connection.query. And the first argument is going to be the context.background. And the second is going to be our query that we're going to pass to the Postgres database. And we're going to say select all from users. Whoops, I forgot one letter. Select. And then after we call the query command, we'll check for an error. If error is not equal to nil, we will return nil and error. Otherwise, if we don't get an error, then we will defer rows.close. Okay, and defer is going to defer the call to close until this function exits. And then what we'll do is loop over the rows that we received, and we will generate a protobuf user for each of the records that we received. We'll append those users to a protobuf users list, and then return the protobuf users list back to the client. So to begin, I'm going to say for rows.next, which will get me the next row, and I will define a new variable called user, and this is going to be a protobuf user type. And then I'll say error is equal to rows.scan, and then I'm going to refer to the address of the attributes of this user variable. So I'm going to say user.id, and then user.name, and finally user.age, so that the fields from the table or from that particular row are scanned into the user, the protobuf user attributes. And after making a call to scan, we will check if there was an error returned. So if error is not equal to nil, then we will return nil and error. And I'm going to move the definition of the users list variable up to the top of the function here. Okay. And then if there wasn't an error, what we'll do is we will append this new protobuf user to the protobuf users list. Okay. So I'm going to say users list dot users equal append users list dot users, and then the address of the protobuf user. And then the last thing that we're doing in the GetUsers function is simply returning the users list back to the client. So now that we've made the necessary modifications to the CreateNewUser function and the GetUsers function, we can modify the main function, and these will be the last modifications that we need to make to the server program before we run this gRPC service again. So in the main function, we need to create a connection to the Postgres database, which in my case, I'm running in a Docker container locally on my machine. So the first thing that we need to do is define the database URL. So I'm going to create a variable called database underscore URL, and we'll set its value to Postgres / Postgres my secret password. Okay, so we're passing in the username and credentials at localhost on port 5432, and then we are connecting to the default Postgres database. And once we've defined the database URL, we can then make our connection to the Postgres database. So I'm going to define two new variables, connection and error. And then we'll call the PGX package, and we'll say pgx.connect. Okay, and then we'll pass in the context.background, and then the second argument is going to be the database URL. After we call connect, we will check for an error. So if error is not equal to nil, we will log fatal. And we'll say that we were unable to establish a connection. And if there wasn't an error, then we will call connection close, but we'll defer that invocation to the close command. So I'm going to say defer connection close and then context.background. And then the final thing that we want to do is set the connection attribute for our new user management server. So I'm going to reference the user management server dot connection is equal to connection. Okay. And the rest of the main function we can leave as is. So before I run the program, I'm going to run go mod tidy in the terminal. Okay, so that I can pull in the PGX module. And the other thing that I want to do is I want to show you the Postgres database just so that you can see that the users table hasn't yet been created. And then we'll, after the program runs, we'll take a look at the Postgres database from the command line to verify that the table was created and that the records were added successfully. So I'm going to open up a terminal window, and I have the Postgres container running, and I'm going to connect to the container using Docker exec. And I'm logged in as root, but I'm going to log in as the Postgres user. And now that I'm logged in as a Postgres user, I can use the command line tool PSQL, and that will log me into the Postgres server itself. Okay, so from here I'm going to connect to the default Postgres database. Okay, and now that I'm connected to the database, I should be able to see the tables in the database. And currently there are no tables in the default Postgres database. So now let's go back to VS Code and we'll run the server program and then we'll run the client program. So that's going to be go run user management server. Okay. And it looks like it's listening. And then in another terminal, I'm going to say go run user management client. And it looks like I got an error here, so let's take a look at what happened in the server. Okay, so I'm not entirely sure why I ran into a segmentation fault in the initial run. On the following runs, the server did work correctly. So it seems like there might be a race condition where a variable is not getting initialized by the time that it's being used or something like that. And if you do spot the error in my code, please let me know in the comments. But I'm going to leave it as is and I'll debug it later. But let's go ahead and run the program again and see if it generates the users in the Postgres database correctly. So I'm going to run go run, I'll just use the up arrow here, go run user management server. Okay, and the server's starting, so I will start the client program. And it looks like the client program ran successfully, and you can see that the users that are generated and returned when the client calls the GetUsers function have ID 1 and ID 2, which were auto-generated by Postgres. So now if I navigate back to the Docker container and I query the users table, I should see those two records in the table. And you can see when I run DT, we have the users table created now. And if I say select all from users, we can see the two records, Alice and Bob. Okay, so IDs 1 and 2. And if I continue to run the client program, we should see additional records added to the table. Okay, so I'll run that again. Now I see 6 records. And even if I were to close the connection with the database that the server has, so I'll stop the server program and then I'll rerun it and I will run the client again. Okay, we see the same behavior, and it does pull all of the users from the Postgres table. So integrating a database into our gRPC service makes it a lot more scalable than our protojson solution. And you can see the behavior of the program from the client's perspective remains the exact same as it did in the previous implementations. Our service definition stays the same and the client code stays the exact same. We just changed the implementation of the server code. So I hope you've enjoyed this series, and if you have, please consider throwing a like on the video and subscribing to the channel for more series like this. If you'd like to see more videos specifically focused on gRPC or focused primarily on Postgres and Golang using PGX, let me know in the comments. As always, the code that we wrote today is available in a GitHub repo that I've linked in the video description below. Thanks for watching.